Okay, we got to asynchronous programming. One of the things that confuses developers is asynchronous versus synchronous execution model. So in this lecture, I'm going to explain the difference between synchronous and asynchronous execution model, and then explain how we can do asynchronous programming with C#. In a synchronous program execution model, program is executed line by line, one at a time. When a function is called, program execution has to wait until the function returns before it continues execution to the next line. Let me show you a demonstration of that. Imagine here we have a piece of code with 4 lines. In the second line, we are making a call to a function that is going to be a blocking operation. It's going to be time consuming. An example of that is when we access a database or a website. So as we run this program, you see that each line is going to be green, and you will notice that in the second line, there is going to be a delay. Let's take a look. So here's a delay. So you notice that we blocked on the second line. Now, in asynchronous program execution, when a function is called, program execution continues to the next line without waiting for that function to complete. So let's do another simulation again. This time, you will notice that the second line executes immediately and the control will go to line 3 and 4. In the second line, we provide a callback to that time-consuming process function. So when the execution of that function is finished, then that callback function will be called. Let's take a look. So as you see, the program runs more smoothly. We didn't block on the second line. So what's the difference? Asynchronous programming model improves responsiveness of your application. You have already seen that in the real world. Think of Windows Media Player or your web browser. In the case of Windows Media Player, as it's playing a media, let's say a song or a movie, the UI continues to be responsive. You can resize the window, you can move it around, you can see an animation. If Windows Media Player did not utilize asynchronous programming, as it was accessing the file system and reading a piece of music, the window would freeze. You could not touch that window. Same for your web browser. As a web browser downloads content from the web, the UI is still functioning. It's responsive. And that's the benefit of asynchronous programming model. So when do we use asynchronous programming? Anytime we have a blocking operation, such as accessing the web, working with files and databases, working with images, and so on. Now, how do we do that? Well, traditionally in C#, we had 2 common approaches. One was using multi-threading, one was using callback methods. Both these approaches are complex to learn and understand. So in .NET version 4.5, Microsoft introduced a new asynchronous programming model, which is called task-based asynchronous model. And we achieved that by using async and await keywords. And that's the topic of this lecture. So let's jump into Visual Studio and learn about async and await. Okay, here I've got a basic WPF application with one form and a button here. And behind this form, we have a handler for clicking of that button. First, let's see how a synchronous operation can affect the responsiveness of our application. So I'm going to create a method here. Download HTML, that takes a URL. We're going to use a web client. And then get the HTML and that URL using download string method here. So download string takes a URL and returns a string, which in this case is an HTML. Now we need to write that HTML to a file on the disk. So let's use a stream writer for writing that HTML to disk. And I'm going to store it in a file here called result.html in my projects folder. It doesn't really matter. And here we use streamwriter.write to write that HTML to this file. Pretty simple, right? Now, in the button click, I'm going to call this method and pass an address like msdn.microsoft.com. Let's run this application. So when I click this button here, it's going to take a couple of seconds until we download that HTML. And during that time, this window is going to be unresponsive, which means if I try to drag and drop it, it's not going to happen. Or we cannot even resize or minimize this window. Let's see what happens. So click, look, it's not moving. Now it moved because the HTML was downloaded. Let's try again. Click. I cannot move this. Oh, there was a tiny delay here. So it depends on the operation. The longer the operation, the more unresponsive the UI is going to be. Now let's see how we can improve this by using an asynchronous operation. So I'm going to write an asynchronous version of this download HTML method. So let me scroll down a little bit so you can see easier. We start with public. All asynchronous methods should be decorated with the async keyword. So we put async here. Now for the return type, we need to return a task object. What is a task? A task is an object that encapsulates the state of an asynchronous operation. It comes in two forms. One is the non-generic form, which is this one here, and one is generic form. So if your method returns, let's say, a string, you need to use the generic version of the task. So that would be task of string. If your method is void, you need to use the non-generic version of task, which is just this one here. So we return task here. Now we name our method download HTML. And by convention, we need to add the async suffix. You don't have to, but this is the recommended practice from Microsoft. And then we're going to use the same parameter here. Now let's copy paste this code inside our new method. Well, at this point, this method is still not asynchronous. All we have done is we changed the declaration of the method. But we are essentially calling a synchronous blocking operation here and here. So we need to change these two blocking operations to asynchronous ones. Now, since .NET 4.5, pretty much most methods that are blocking operations have an asynchronous or non-blocking version. And they all end with the async suffix. So let's have a look here. So in the web client class, we have download string, which is the synchronous version, and we have task async and async. This async method here is a legacy one, and it's got nothing to do with the new asynchronous programming model in .NET 4.5. So this is the one we're going to use. And as you see, it returns a task of string because the original method returned a string. Now the asynchronous version returns a task of string. So we're going to use this method here. And typically when we call an asynchronous method that returns a task, we need to put an await operator here. What does it mean? In the first glance, it may give you the impression that the program execution has to wait for this method to complete, but that's not the case at all. This is just a marker for the compiler. So when the compiler sees that, it knows that this operation is going to be costly and it may take a bit of time. In that case, instead of blocking this thread, it's going to return the control immediately to the caller of this method here. So the thread here is not going to be blocked and the control immediately returns here. And here we exit this button underline click method, which means the UI immediately becomes responsive. Now at some point, this method download string task async is going to be completed. And the runtime is going to be aware of that because we marked this with await. So when this method is completed, runtime comes back here and executes the rest of this method. So the interesting thing here is if you compare these two methods, they look pretty much the same, except that in this method, we have an await here whereas we don't have that here in the original synchronous version. But at runtime, how this code is executed looks different. It's like you have two different methods. One is one that includes only these two lines, and there is another method that is a callback once download string task async is completed. In that case, that method will be executed. We as programmers do not have to partition our code in terms of functions and their callbacks. And we are giving this hard task to the compiler by using the async and await keywords. Now, interestingly, this stream writer has a write method here, which is again a blocking operation. So we can improve the responsiveness of our application even further by using the asynchronous version of write method. So look, we have write async, write line, and write line async. So pretty much, as you see, for all synchronous methods, we have an asynchronous version. I'm going to use the async one. And as I explained, we need to put await here to let the compiler know that this method is going to take some time. So it returns the control immediately. And the executing thread is not going to be blocked. Now, in the button on the line click, let me call the asynchronous version of this method and see how it makes a difference. So this time I'm going to click this button and note that the window is not going to be frozen and I can immediately move it around. So click, see, it's very responsive. One more time, it's responsive. Let's close this, get back to our original synchronous method. I click this button. It's not moving. It just moved now because the synchronous operation completed. So the use case for asynchronous programming is if you are building WPF applications or applications for the Windows runtime, wherever you have blocking operations like accessing files, accessing database, calling web services, or accessing web as you see here, accessing the calendar address book on a Windows mobile, all of these are blocking operations, and you can improve the responsiveness of your application by using async and await. What about web applications, like ASP.NET MVC applications? Well, in those applications, the UI is not in the same process. It's on the client's machine, in the browser. So does the new async programming model improve web applications? Yes. How? Well, typically, in a web application, when a request comes to the server, a thread is allocated to handle that request. Now, during execution of that request, if there is a blocking operation, that thread is going to be busy. And each machine, as we know, has a limited number of threads. So if we have a lot of concurrent connections, and all our threads are busy waiting for a blocking operation, that server becomes unresponsive. And the only way is to add more servers, which is scaling out. We can improve this by using an asynchronous model. So when a thread has to execute a blocking operation, the control immediately returns to the thread, and that thread can be used to handle another request. When that blocking operation completes execution, again, the same thread or another thread will come back here and pick up the rest of the program and continue execution. So with this model, we can scale up instead of scaling out. Now, that doesn't mean that if you design your application poorly, this is going to help you significantly. Not at all. But this is just a new practice and a recommended practice. So whenever you are using blocking operations, you should use async and await. Now, let's get back to our example here and see another use case. This time, I'm going to create a method that returns a string. So instead of being void, I want to return a string. So let's collapse these. Create a new method here. Get HTML from a URL. Similarly, we're going to use a web client and return web client.download string from that URL. So in the button on the line click, I'm going to call this method, get the result, and display it. Sorry, I need to put the address here. Okay, now we got the HTML and let's display it in a message box. Now that HTML is going to be huge, so I'm just going to get a substring of that. Let's say the first 10 characters. Let's run this application. So I click this button and notice there's going to be a delay until we get the result. And during that delay, the window is going to be unresponsive. So can't move. Now we got the message box. So here's the beginning of the HTML. I click that and now UI is responsive. Let's make this asynchronous and improve the responsiveness of our application. So we start with async. Instead of returning a string, we need to return a task of a string. So task of a string. Call it get HTML async. Takes a URL. I'm going to copy paste this code into here. Now this time, instead of calling download string, which is a blocking operation, I'm going to call download string task async. And as I said, this method returns a task of a string, as you see here. So we need to await that to tell the runtime not to wait for the result of this method and continue execution. Okay, now here in button on click where we call get HTML, we're gonna replace this with get HTML async. Now the compiler is complaining. Why? Because this HTML is a task of a string. It's not the end result. It's a task object that represents the state of an asynchronous operation. So it doesn't have methods like substring. So we need to await that here to get the actual string. But interestingly, we got a red error here. Let's see what is here. It says the await operator can only be used in a method or lambda marked with the async modifier. What does it mean? Here we are awaiting for an asynchronous operation, but this method is not marked with async. So we need to change that to async, and now the error is gone. So the lesson is you can only use the await keyword or the await operator in an async method. Let's run the application. Click the button, window is responsive. Now we got a message. Let me show you something else here. We don't always have to await this asynchronous method straight away. Let's see what happens if we don't do that. So I'm going to remove this, and now this object is not the HTML, it's a task. So let's rename it to task of, let's call it get HTML task. And here I can say the actual HTML is await get HTML task. What does this mean? Well, when we call this method, the control immediately returns here. So we have a task object that represents the state of that asynchronous operation. Next, we come here and we are telling the runtime the rest of this method cannot be executed until this operation is completed. So the control immediately returns to the UI, and that's why the UI is responsive. But when that operation is completed, the rest of this code is going to be executed. At this point, we get the HTML and we display the message here. Now, what happens if we put a message box here? Let's say, waiting for the task to complete. Now with this code, as soon as we call this method, control comes here immediately. We get this message, and then UI becomes responsive. Once the HTML is downloaded, then we get another message. So let's run the application. Look, I click this button. We immediately got a message. Now the task completed and we got another message. So what I'm going to tell you here is you don't always have to await an asynchronous operation, and you can do instead some work in between that is not dependent on the result of that asynchronous operation. So this way, you can utilize a thread to its fullest potential. You use await when the rest of that method cannot be executed until the result is ready. Well, that's pretty much it for this lecture. I hope you enjoyed and thank you for watching.